Hello. Hello again. Today I'm going to show you essentially how to get to this point where you have a 100 by 100 kilometer squared environment in Unreal Engine 5.5. It is going to be a very kind of quick tutorial, as quick as it can be, because people moan about the length of my videos. And really, I should just go, shut the fuck up. But I'm going to try and make it a bit quicker. Um, so yeah, we're going to get going and see if I can make it faster than my usual videos. Um, Probably won't end up being that much faster. Um, but yeah, this is the goal, and this is what we'll get to. I want to quickly say before I do continue that my fab product, the heightmap product, is going to be updated with these maps. So if you do not want to bother to follow along, you will be able to grab these maps from here. And when I say these maps, there is going to be a new 10 by 10 kilometer folder with the sandy one, which is what we're looking at here, and a volcano map, which I will quickly open and show you here, which is this one. They have rivers, obviously hills and mountains. This one's got a kind of old volcano, collapsed volcano. And yeah, just the kind of nice base level for you to kind of work from. There's obviously going to be a lot of work to be done as far as optimizing these maps and getting them to do what you want. But yeah, they'll be in the pack, as well as a no edit layer version of the sandy one, so you can check whether that is better for you. I'll probably add the volcano one with no edit layers as well. As well as the actual heightmap files with different resolutions. So currently in this tutorial I'm going to be just showing the 4K one, because obviously the resolution is higher and it will look better. It will look like this. But there will be the lower resolution height maps in the project for you to use if you wish to downgrade the resolution for your project. And you might want to do that if you're doing like a low poly project, or you just want to use these height maps at smaller scales, and you want to use lower resolutions. So without further ado, let's crack on. So I am going to show you the volcano mountain. We might as well use this one because this is the one we're at, and I will show you how to get to this stage from scratch. So we open a new level, and I'm going to do a new empty open world. And at this point I would say you want to save it wherever, and you can do that. You know how to do that. We want to come into the landscape mode, and for this one we're going to be doing 4K. So initially I'm actually going to ignore these. I'm going to leave these. This is to do with the region sizes, which I've covered in loads of other videos, and this is your edit layers on or off switch. Now if you have edit layers on, you will obviously be able to utilize edit layers, and this is very good for smaller landscapes. But if you are dealing with massive terrains, I would suggest flicking this off, just because once you start adding things like a landscape material, your VRAM on your GPU is going to start, the usage on there, the memory usage of your graphics card is going to start going up rapidly, and this only adds to that stack of resource usage. So in this example I'm actually going to turn it off. You don't have to do that. It's up to you whether you want to. You can test these things as you want. But in this case, I'm going to turn it off. The next thing to do is to determine these kind of basic settings, which I would suggest you check. I'm just going to get it up. The UE5 landscape documentation, and you will have this page called the Landscape Technical Guide on the UE5 documentation. And if you go down to the bottom, roughly, you get this recommended landscape size. This will be the one that I am following. So it's in order for you to get the right sizes, you need to match these settings to these settings. Now it can be confusing because these are in different orders to how these are viewed or showcased, sorry. Just one thing to note is that the number of components value here doesn't relate to this 126 by 126. It relates to this one, which is the 32 by 32. Just so you know that, because that one is the one that can be confusing. All the others are easy to work out. For example, the quad section size is 63, which is this one. 2 by 2 is this. Just get that back up. So that's 2 by 2 is this, which gives you your overall resolution. But then to increase the components, you have to change this value. And then if you type in 126 by 126, you're going to get a crazy high amount of components. So you want to just follow this number, which is the 32 by 32. And then you'll get your correct total components amount. Now this is the number that matters. You want this as low as you can, generally, to limit the amount of resources that it's going to cost for your terrains or your landscapes. And obviously just to follow these recommended landscape sizes is always recommended. So we have got those base settings done. Now we need to calculate our size to get the correct kilometers squared. And as you can see, right now we're at a 4K size because we are just scale of 100, which is basically like 111 relative to our resolution. So we are going to be at 4 kilometers if we was to create this, and we want 100 kilometers. So this is where the important part comes in, and that is our formula for scaling up, essentially. So with this, we want to logically use a calculator to make sure we get this right, because my maths isn't great. And we want to use the two different calculations to get our XYZ values. The first calculation being our X and our Y, which is our what am I saying? This red and the green scale value, XY. And then a second calculation for our Z axis calculation. These can also be found, well, the Z one can be found right here, calculating heightmap Z, and calculating the heightmap dimensions X and Y is here if you want to go through and have a look at that. But I'm just going to show you here. So in order to get our X and our Y, which will also of course be the same amount, we take our desired size in kilometers, times it by 100, and then we divide it by the resolution size of our height map. So in this instance, I'm going to edit this. This is going to be our calculation. So this is the size in meters, I believe. Times 100 divided by 4033, which is the size of the height map resolution that we're using. So I'm going to do 100,000 multiplied by 100 divided by 4033. Now this gives us our massive number, and I'm actually going to round this to the nearest decimal place, and I'm going to go for 2,480. 2,480. I should actually round it down, but I'm not gonna. I'm gonna round it up because more is better. So 2480 gives us our x and our y scale. At this point, I should mention that this calculation can be used for any situation. So if you was to change that number, sticking with this height map resolution, you know, if you wanted 80 kilometers squared, this would be 80,000 rather than 100,000. If you wanted 50 kilometers squared, this would be 50,000 instead of 100,000, etc., etc. Also, the second number would change if your resolution of your height map is different. So if you was using the 2017 2K resolution height map, you would change the second number to 2017. But in this case, we're not, so don't. That is just for future reference, okay? So we've got that done. Now we want to do our Z-axis calculation. Now I know from trial and error that I need to kind of set this to around 10,000. In this case, I'm actually going to change it to 9,000, which is essentially talking about meters. I think I designed it for 5,000, but it doesn't look very good, and I think I might have exported something slightly incorrectly. So yeah, I think it's going to be around the 9 to 10,000 mark, and that is this calculation, which is coming from the documentation. So I'm going to do this one because it's simpler, but they basically get you to the same thing. So just don't worry about that. Just remember that it is whatever your height in meters, desired height in meters, multiplied by 100 divided by 512. And you can read through the documentation if you wish to understand that more deeply. But because people moan about my videos and their lengths, I'm not going to try and explain it. Okay, divided by 512. Then we get this number of 1757.8. So I'm going to go for 1758. 1758. Okay, so you've probably noticed that I am on Create New instead of Import from File. Now I've chose to do this because I think that the process of creating the template for your height map and then adding your height map is easier on the machine rather than going straight for Import from File, and I get less crashes and it just works smoother. So I would always suggest to do what I'm doing now rather than import from file. So once you've done all this, you've got your calculation input and all your base settings, we just hit create. This is going to ask us to save. I am going to save it in my no edit layers. I'm actually going to say I'm going to take this name and I'm going to save it in here. No edit layers. So you save your map and import. That's usually why I would say save before you hit create. And then this is going to run through everything, create your regions, and create everything that you need. And I'm going to leave it in real time because I don't really like not showing the full process. I think it's better to see the entire process from start to finish. And obviously my machine is quite a hefty one. I have an i9 water-cooled processor with a 4090 graphics card, 128GB RAM, all that stuff. So it does it quite reasonably. And now we have, as you can see, this is usually a good sign if you have regions floating about. And you can see everything's kind of worked. One thing you should always use, I have this window open here, this world partition window, which you can get by going window, world partition editor, and that will open this window. And this kind of is just my kind of final check to see whether or not I've got the correct sizes in all my regions in the right place. And you can see we're at 99.99 kilometers by 99.99 kilometers, so I'm just under 100 by 100, probably as close as you can get without it being 100. So I would have just had to have made some slight increase in my scale for my landscape, but I'm happy with that because it's basically the same. What we can do then is click and drag over these regions, which are these big purple volumes, and then load selected regions, and you'll see we have our terrain. I keep saying terrain, but it's a landscape in Unreal. And there we go, we have our landscape. And then, in order to add the actual height map, we want to come into Manage, the Manage tab within Landscape mode, hit the Import section, tick height map file, and then go and find our height map. In this instance, we're doing the volcano mountain, and I'm going to select my file on the other window, which you can't see, and this will come up with this green grid showing you that you're about to import it. Now, because I've got import mode loaded only, that is why I loaded all of the tiles beforehand. You can attempt to try all if you don't want all of the tiles loaded before you do this process, but I tend to load them, import the height map, and then we can see that the whole map has imported correctly. Okay, so that is good for me, and I'm going to hit import. And that looks like it's done. That happened very quickly actually. So now we can come out of landscape mode and we can see that we have our height stuff working correctly. Now obviously the map doesn't look very good because we have no lighting in our scene. I'm going to quickly create a new folder called lighting. I spell that correctly? Yep. And I'm going to save everything. Okay, at this stage we want to then start dragging in our lighting stuff. I have obviously got these from previous ones, but you can type in these up here, like directional light for example. You drag that in and that gives us a little bit of light on our scene. Then I want to drag in the sky atmosphere, skylight. We'll go for the volumetric clouds first, and the exponential height fog. And that's basically the raw basics. I'm then going to quickly add those to our lighting folder and save. So we do get these kind of strange issues and with the fog and the sky atmosphere. I'm pretty sure it's the sky atmosphere causing these issues, and I haven't really dug into the specific reason that causes it. There's going to be a lot of potential reasons, which is why generally I use ultra dynamic sky as my kind of lighting option, because it kind of just gets rid of a lot of this crap. But one thing I'm going to try is just raising up the terrain, because that seems to help a lot. It is probably better to be kind of zeroed out with your terrain, and this is the best time to kind of do it, is to zero out your terrain generally here, because you can't really change the height of these, you can't really lower the height of these things without it causing problems. So, you know, I'm not really going to actually change the height just because I want to stick to the landscape being at 0 at the moment, because it's good practice. But you do get these horrible kind of height issues, and you can see that once we actually go up to a reasonable kind of height, we don't have those problems. But yeah, we can get around it in different ways. For now, I'm just going to continue with what I was here to show you. So, if I hit play now, we're going to see not very much of our terrain. And that is to do with the runtime settings. You can find those when you press Settings, World Settings. We come up with all these various tabs here. There is an option called Runtime Settings. And then in there we have Runtime Partitions, Index, Main Layer. So this is essentially our well-partitioned grid and all of the settings for it. And then we have our HLOD, which is another more advanced subject that I do kind of touch on in other videos if you want to go check that out, which is definitely what you should be doing instead of what I'm about to do. So if we turn on this preview grid, you can sort of see these options here, which you can change the color if you want. Not that you need to, but I'm going to go with green for now. And basically, this is showing you what is going to be loaded from, this dot can be thought of as the player camera position, and everything within these tiles are going to be what are loaded. And as we change this number, increase it or decrease it, you can see that this sort of starts to spread across. This is essentially the loading range. So if I just pick one like this, as you can see, when I press play, we're going to get a slightly further loading range. And as you increase that, you increase the loading range. So it's always worth kind of playing with this, and the whole point of World Partition is to sort of give you the control of this and allow you to be as optimal as you can, because really you don't want to be loading the entire landscape. It will eventually start damaging your performance, especially once you get things like trees, the material itself on the landscape, rocks, buildings, blah blah blah. You're going to want to start to optimize how you do this thing overall. So that's where HLODs come in at a later stage, where you would have, a HLOD is like a lower resolution version of your distant landscape, blah blah blah. And you can play with the LOD distance of your landscape. But for now, I'm just going to be putting this up to like a quite obscene distance. Oh. So that we have a full kind of visual range. And I'm going to turn off our preview grid. And they can stay open, but I'm not gonna really care about those. And I'm gonna give it a save. So yeah, really, that's a different subject for optimization. But we have got ourselves to this stage of having our landscape. And it runs. And if I hit full screen and go stat FPS, we can see that we're running at 120 frames a second. Obviously on my machine is, it's going to be different to yours. We do have those issues with the kind of flickering shadows in distance. And there are ways around that. If you raise the height of the landscape, that seems to kind of get rid of that. But it's not exactly what we're meant to do. We're probably going to have to look into using things like blending, distance blending for the fog and all of that sort of stuff. But I hope that is a good enough kind of introduction to the whole, scaling up your landscape, and gives you a good enough insight to be able to do these things yourself. This terrain is obviously huge, absolutely massive, and you can see we're starting to get a few issues coming up, few errors. But overall, it does what it's meant to do, and there you go. I hope that helped. As a second thought, at the end of the video, I do have a product on Fab. If you would like to purchase any of these products, that would be greatly appreciated. Obviously, the levels that are going to be have been showcased in this video are going to be in this heightmap starter pack. The link will be in the description to the Fab product. We also have our pots collection. This one is actually more than just the pots collection. This has a very cool adaptive camera, which basically allows the focus of the camera to be on the up close objects as well as the distance objects. So if you look at something, it will basically focus on it, whether it's in the distance or close, and the camera will adapt. So that's in there, which is how we obtain those photographs. I'll say me, and yeah. So those pots I think turned out very nice, and we'll be expanding on that. And also we'll be expanding this heightmap one as I go. Yeah. So yeah, if you could jump in and buy those, that would be great. Help me out and keep me wanting to do more, basically. So yeah, hopefully that helps. And good luck with your projects, and see you on the next one.